Hello everyone, and welcome to a new video modeling the University of Greenwich with Threedee. Today we will focus on creating what we will call the grand column entrance of the university, and we will then integrate it into our main project. So let's get started, and just don't forget to download Threedee's free version in their website. In this video, we will focus on the use of variables. This way, we will be able to change the dimensions later on if needed on a much easier manner. Feel free to stop the video where the variables are shown if you'd like to use the same dimensions as we are using. As usual, we will start in the input node, creating a compass sketch of 60 by 20. We will create a cut node, creating two nodes from north to south. This will be parallel to base 1, and the distance between each cut and the outer edge will be 20%. We will then label the edges of each section by clicking in the compass icon placed on the top, and we will label the middle section as center and the two outer sections as sides. Once we render the image, you can see that our base is now divided into three sections. We will then create a select node, selecting the labels that we just applied in our base, sides and center. Combining cut and select nodes will allow us to form the basis of the structure and also allow for precise alterations later on. From the sides, we will create another cut node with 4 cuts that will be parallel to the south. Now the exact distance between cut 0 and base 0 will be wall depth, as well as the exact distance between cut 1 and base 2. The exact distance between cut 1 and cut 2 and between cut 3 and cut 0 will be wall thickness. We will label the edges of all the resulting sections using the compass on the top menu, and we will label the center section as 2, and the remaining 2 inner sections will be labeled as 1. The result of this will be that the sides are divided now into 5 different sections. We will repeat the process, creating a select node with the labels 1 and 2. From the output node of label 1, we will create an extrude node, where the label south will use the profile called wall exterior. Now bear in mind that this profile has been previously created, as shown in other videos. Feel free to pause the video when needed to follow along. From label 2, we will create an extrude node by amount, using the variable ceiling height and renaming the side faces to invisible. These variables act as adjustable parameters, giving us the power to define dimensions dynamically. Variables and parameters in Threedee can be adjusted on the fly, which means model can be dynamically modified without the need to rebuild them from scratch. From label 2, we will also create an extrude node by amount with the variable floor height. To place the columns of the walls, we will create a repeat cut from west to east, by length, where the distance will be the variable wall section width. Now this will have a secondary distance of 0.05 and a margin start of 0.05. All secondary faces will be labeled as 2. We will select again label 1 and create a cut node with 2 cuts from north to south. This will be parallel to the east, and the distance between cut 0 and base 3 and between cut 1 and base 1 will be the variable wall column width. Don't forget to label the edges by clicking the compass icon, and the outside sections will also be labeled as 2. To finalize this part, we will select label 2 and create an extrude node where south, east and west will use the profile wall column. As a result, we have the columns extruded and can be modified at any time. We will move into the ceiling, where we will create a combination of extrudes and inset nodes to achieve the desired outcome. Threedee emphasizes procedural generation, which enables users to create models algorithmically. Now this is particularly useful for repetitive or complex structures that could be time-consuming to model manually, such as the University of Greenwich. Something that I have realized while using Threedee is that this node-based procedural system means you're not just building models, you are crafting rule sets that generate models. It is a shift from manual sculpting to intelligent design. Nodes like cut and extrude become reusable components acting as building blocks that respond to our creative commands. Going back to the first select that we created, we will add an extrude node from the center output in order to create the ceiling. This will be by amount using the variable ceiling height and labeling the side faces as invisible. From the caps of this extrude, we will create two more. The first one will be using a fixed profile, ceiling, which will create the curved detail of the interior. The second one will assign labels east and west to a profile called roof sides, and labels south and north to a profile called roof front. This way the main structure of our building is ready. Taking into consideration that one segment of the profile roof front was labeled as 1, we will create a select node from the sides of this extrude and select label 1. Then we will create an inset of 0.8 and finally an extrude by amount of -0.5, adding detail to the roof of this section. We will go back again to the first select, where we will create a cut node with several cuts. Cut 0 and base 2 will have an exact distance of the variable stair length, as well as cut 2 and base 0. The distance between cut 3 and cut 2 will be the variable called base width, as well as the distance between cut 0 and cut 1. Then cut 4 and base 3 and cut 7 and base 1 will also have an exact distance of the variable called base width. Cut 5 and cut 6 will have a distance of wall inset, same as cut 8 and cut 9. With that, we will label the top and bottom sections of the as a stair area. The sections next to those will be labeled as south, the corners remaining as 2, and the rest as north. Next, we will create another select with the labels south, 2, and north. From the south output, we will create another cut node with 3 cuts from north to south. Now we need to be careful here and make sure we declare a fact to place cut 0 in the middle of base 0. I didn't do this while recording the video, and it caused some issues while integrating the function into the main project. Once this was fixed, everything worked as it should. Cut 2 will be parallel to cut 0 and have an exact distance of the variable stair width, divided by 2. Cut 1 and cut 0 will have the same facts applied. The middle sections remaining will be labeled as north, and just don't forget to label the edges by pressing the compass icon on the top menu. Thanks to the non-destructive nature of Threedee, I was able to fix the errors that came across the process without the need of starting from scratch all over again. After, we will select label south and create an extrude by amount of the variable stair height. We will connect the output of label 2 from the first select that we created in this section to the extrude node. And just remember to add another input node to keep everything nice and tidy. We will create a repeat cut and another select node with the labels east and west. From the east, we will create another extrude node where labels north and south will use the profile inside wall. From the west, we will create another extrude that will allow us to start creating the columns. This node will have labels south and north using the profile column base. Another thing that is important to add is a merge node between the extrude and cut nodes that we just created. This will make sure that the geometry that we want to access is in the same layer. The cut node will be fairly simple and will make the division to add the columns. We will select label 1 and add an inset of 0.1, followed by the polygon tool provided by Threedee. Now the number of sides for this tool will be 24 with a range of 10 and a step of 1. To finalize this section, we will create another extrude by amount where the amount will be column height. Back to the first select of the lower level section, we will merge the faces of the north section and create an extrude node by amount using the variable floor height. As you might be able to see in the results, there are 2 columns missing in the final render, but by tweaking those little details I was talking about, everything should be fixed. We will export this project as a function and import it into the main project. We will just need to add it into the ground column entrance output, and we are just a step closer of finishing this building. Don't forget to like, share and subscribe, and I will see you in the next video. Thank you very much for watching.